1033, Chapter 3, Section 5. Still dealing with functions. Example problem 1 just deals with being able to graph a line, a linear line, with slope-intercept form of the equation. Notice I put the y-intercept in red. Make sure you understand that even though in the equation it's just a plus 3, that it's really a 0, 3. So whenever to ask for a y-intercept, you're going to the y-axis and plotting 0, 3. That's the first thing we plot. From that 0, 3, we're going to move the slope. See how it's positive? So it's a plus on top, plus on bottom. So we go up 1 and over 4. That's where we get the green point. We got our 2 points. We graph. So remember, when you're graphing a linear equation, you're always plotting the y-intercept first on the y-axis. Then from the y-intercept, you move the slope. Positive slope up to the right, negative slope down to the right. Then we come to example 3. And example 3 says write a slope-intercept equation for 0, -3, and m equals 1/4. Well, first of all, because 0 is in the x position, I got to understand that this is a y-intercept, so this is b, so it's a -3. M is the variable for slope, so this is 1/4. So it's y equals 1/4 x minus 3. Next, I'm just going to do this example straight from the book. We go to point slope form. Notice in point slope, the y1 and the x1 are my point, the m is my slope. Y will always be y, x will always be x. If we look at example 4, it says find an equation of the line with slope -3 containing the point 1, -5. Put the equation in slope-intercept form. So the -3 is the m, so we put it in place of m. The -5 is y1, so we put it in y1. The 1 is x1, so we put it in x1. This becomes y plus 5. We distribute the -3, -3x plus 3. Subtract the 5 over. We get y equals -3x minus 2. That's really all there is to it. We'll do a problem here shortly where we have a fraction for the slope. And we're just going to do what we learned in solving algebraic equations. We're going to multiply through the whole equation by a number so that we get rid of the fractions. Okay, this is example 6 in the book. And what example 6 says is we have a point -1, 2 and a point 3, 5. We want to know the equation in slope-intercept form of the line that goes through these 2 points. Well, the first thing we do is we label -1, 2 as x1, y1, 3, 5 as x2, y2, put them in the slope formula, and get the slope of 3/4. Next, we're going to take that slope of 3/4 and put it in for m in point slope. And it doesn't matter which point you use. You can use either point, you're going to get the same answer. I highly suggest you use the point with the smaller values. So we're going to use -1, 2. So we put -1 in for x1. Of course, we're subtracting, we mentioned it was +1. We put 2 in for y1, and here we are. Now, because we have the fraction, I'm going to get rid of the fraction. Because it has a denominator of 4, I'm going to multiply the whole equation by 4 over 1. So when I multiply y by 4, I get 4y. When I multiply 2, I get -8. Now here, I only have to multiply the number outside the parentheses. Because when I multiply 4 over 1 times 3/4, I get 3. That means when I distribute this 3, both of these numbers are in there. So I don't have to multiply inside the parentheses. Distribute the 3, I get 4y minus 8 equals 3x plus 3. Then what I'm going to do is I'm going to so remember, when you're solving this, distribute the 3, we get 3x plus 3. So what we really want is we want the x term to be positive. So what I'm going to do is I'm going to subtract this 3 over, which gives me -11. I'm going to subtract this 4y over, which gives me 3x minus 4y. Okay? So then what happens is I'm going to subtract the 3x over. So then what I get is I'm going to subtract the 3x over. I got negative 3x minus 11 equals negative 4y. Then divide by negative 4. So now I get y equals 3/4 x plus 11/4. And all I did was divide by negative 4, divide by negative 4, divide by negative 4, and then just switch sides once I finished. I'm going back to what we talked about in a couple other sections. Example 8 says find an equation of the horizontal line containing the point 2, 3. Well, if it's a horizontal line, it's a line going through whatever y is. So as everybody sees that it's y equals 3. If you come down here to this one, it says find an equation of the line containing the point 2, 3 where the slope is undefined. Well, if the slope is undefined, it's x equals whatever x is, so it's x equals 2. There's that connection between the fact that, if you have a zero slope or a horizontal line, it's always y equals the number in the ordered pair, because all the ordered pairs are going to have the same y. Here, if you have an undefined slope or a vertical line, it's x equals whatever numbers in the x of the ordered pairs, because all the ordered pairs are going to have the same x. I'm going to come to example 10. And in example 10, it basically tells us to find an equation of the line containing the point 4, 4 and parallel to the line 2x plus 3y equals negative 6. Okay? So we got the point 4, 4. We got the equation. So there's a line that goes through this point that's parallel to this line. So what we do is we take 2x plus 3y equals negative 6, subtract the 2x over, divide by 3, we'll find out the slope is negative 2/3. That means the slope of this line going through this point is negative 2/3. So using point slope, we have y minus 4 equals negative 2/3 times x minus 4. Remember, the lines are parallel. So the slope of this one is the same as the slope as this one. Again, we're going to multiply through by 3. We get 3y minus 12 equals negative 2 times x minus 4. That gives us 3y minus 12 equals negative 2x plus 8. And basically what we did here, or what I did here, was I switched sides. I just moved this over here and this over here. Now I'm going to add 12, which gives me 20, then divide by 3. And now I have the equation of the line going through the point 4, 4 is y equals negative 2/3 x plus 20/3. Notice the equation of this line, negative 2/3 is the slope. The equation of the line that was given us in the problem, negative 2/3. Next we come to example problem 11, which we're going to use the same point, same equation, but now we're going to find the line that's perpendicular to this line, but going through this point. So we go through the same process. Subtract the 2x, divide by 3, we get y equals negative 2/3 x minus 2. Now remember the relationship of perpendicular slopes. Perpendicular slopes have to be opposite in sign, reciprocals of each other. In other words, if I multiply the two together, I should get negative 1. So whereas this is negative 2/3, this is going to be a positive 3/2. If I were to multiply negative 2/3 times 3/2, I would get negative 1.